All right, in this problem we're going to graph the solution to the system of three different inequalities here. What that means is we're going to shade the feasibility region. We're going to shade the solution, which we call the feasibility set or the feasibility region. Okay, so what I'm going to do is solve each of these, get y by itself on the left-hand side for each of those inequalities. So for the first one, I'm going to get y less or equal negative 3 over 2x plus 4. All I did is subtract 3/2 x from both sides. For the second inequality, I have to add 2x. So y less or equal 2x plus 4. So I just added 2x to both sides. And then this one is already in the good form. Y greater than or equal to 1. Since all of them have an equal sign with the inequality, I'm going to use solid lines for all of them. And y less than means I'm going to do a lower half plane. Y less than means a lower half plane. Y greater than means an upper half plane. So here are the three constraints or three inequalities. Let's start off by graphing the lines. And I don't need to write them down, but maybe I will. We'll start off by graphing the lines y equals negative 3 over x plus 4, y equals 2x plus 4, and y equals 1. So I'll do this one first at the bottom. Y equals 1 is a horizontal line. Missed that a little bit. Here's the origin, so this is 1. This function has a value of 1. All right, the first one has a y-intercept of 4. 1, 2, 3, 4. And it has a slope of negative 3 over 2, which means from that point we're going to go down 3 over 2. Down 3 over 2. Okay, and then the next line, y equals 2x plus 4, well, it has the same y-intercept as above. That's not a very good line. It's supposed to be going right through that point. So here's the y-intercept, and the slope is 2, which means up 2 over 1. Up 2 over 1, or down 2 to the left 1. So from here, down 2 to the left 1. Down 2 to the left 1, and so on. Okay. Well, you may already know which region I'm going to shade. I think it's going to be this triangular region, because we have to be in the lower half plane. We have to be lower than this line, the lower half plane. But we also have to be in the lower half plane of this one. That would give us this whole triangle area here. But the third line is y equals 1, and the inequality is y greater than or equal to 1, so we have to be above this line. So if you were to shade the three half planes with three different colors, the only region that would be shaded with all three colors is this region right here, and that is the solution, the feasibility region, this triangle. Okay? Next problem. We need to maximize an objective function. Here's our objective function that we need to find the maximum value, maximize this. So we're going to find the x and y values that give us the biggest possible value in the feasibility region, which remember, it always occurs at a corner point, a vertex they call them. All right, so it looks like all of these are written in the good form. We've got y on the left of the inequalities, and remember what these two mean? X greater than or equals 0, y greater than or equal to 0 means we're only in quadrant 1. So this graph is only quadrant 1. The origin is that point right there, 0, 0. Okay, so I'm going to graph these two lines by replacing the less than or equals with equals. Negative 4/3 x plus 20, and it's going to be, they're both going to be solid because they have the or equals part with the inequality. And this one is going to be, we're going to shade the lower half plane. So underneath that line. Line number 2 is negative 1/2 x plus 10. And again, lower half plane. All right, here goes nothing. The first one has a y-intercept of 20. Wow, let me count these. Okay, very top. That's 20 right there on the y-axis. And the slope is negative 4/3, which means go down 4 to the right 3. Make sure you count right here. 1, 2, 3, 4 to the right 3. Down 4 to the right 3. Down 4 to the right 3. Down 4 to the right 3. All right, let's make that line. All right, and so far, we would just shade this, since we're staying in this quadrant because of these final two inequalities here, so far we've just got this triangle as our feasibility region. But we have another line now and a half plane to shade. So y equals negative 1/2 x plus 10. Let's go up 10 for the y-intercept. Right there. And the slope is negative 1/2, so go down 1 to the right 2, down 1 to the right 2, down 1 to the right 2. Okay, let's draw that line. All right, we've got the two lines drawn. So what region are we going to shade, and how many sides does it have? I think you can figure out that it has 4 sides, because we're not going to shade this region, because this region's in the upper half planes of both. We're not going to shade this region. It's in the lower half plane of this line, below this, but it's not below this one. And we're not going to shade this region. It's in the lower half of this one, but not this one. So the only region that's in both lower half planes is this region. That has 4 sides, but more importantly, 4 corner points, 4 vertex points. This one, that one, and that one. Okay, so now we need to find the value of the function at each one of those corner points, because the maximum and minimums always occur at the corner points. So let's write down the vertex, make a little table, and then z equals 5x plus 3y. Let's put our 4 vertex points here. Well, 0, 0, that's not going to be the winner. I know that. This point would be 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, comma 0. This one was 0, comma 10. And this one, it fell on a nice point there. We know exactly what that is. It's 9, 10, 11, 12, 1, 2, 3, 4. If I counted correctly, it's 12, comma 4. Yeah. All right, so this we know is 0. If you plug in x equals 0, y equals 0, right here, you get a 0 for z. This says X is a 15, so that would be 5 times 15, which is 75. I left off the plus 3 times 0 because y was a 0. So far we've got 0 and we've got 75. And then we've got x is a 0, so I'll leave that off. This is just 3 times 10, which is 30. That's not the winner. And then 12 and 4. So 12, 5 times 12 plus 3 times 4. Let's see what that is. That's 60 plus 12. And that's equal to 72. So that's not the winner. This is the best one right here. This is the highest number. So the maximum value of the objective function, subject to the following inequalities, the constraints, is simply 75. The answer is 75.